In this video, we're going to evaluate the integral of tangent to the fourth of 2x. So this is a trig integral, and a lot of times in these we'll use some basic identities, sometimes some half-angle, double-angle identities, along with standard U-substitution in some cases. I'm going to break this up. Don't want to mess with tangent to the fourth here, so let's break this down into tangent squared of 2x and multiply that by tangent squared of 2x. We can't find a representation for tangent squared of an angle. That's why I wanted to do it this way. So this is going to equal to then the integral of tangent squared of 2x. And I'm going to replace this. Well, let me show you first. There is an identity that says if you have 1 plus tangent squared of an angle, whether it's an x or a 2x or theta, this will equal to secant squared of that angle. So 1 plus tangent squared of whatever angle this is. I could say x and x here, or in this case the argument is 2x and 2x. So I have a representation for secant squared. I could also solve for tangent squared by bringing the 1 over, and so on. So for the first tangent squared of 2x, I'm going to leave it the way it is. And for this one, tangent squared of 2x, I'm going to replace that by secant squared of 2x. Minus 1. This will be dx here. And this is again secant squared here. Now I know the derivative of tangent is secant squared of x. I got tangent here, so let's do this. I'm going to let u do a U-substitution here. I'm going to let u equal to tangent of 2x. Then du is going to equal to derivative of tangent is secant squared of 2x, and then using the chain rule, I'm going to multiply this expression by the derivative of 2x. So that'll put the 2 out here. Derivative of 2x is 2, and then I'll rewrite this as divide by 2, then du over 2 would equal to secant squared of 2x, and I've got the dx here and over here. So I'm going to break this up into two integrals. Multiply through by secant squared here, or multiply by tangent squared of 2x, I should say. I'll get this. And multiplying here with the secant squared. So this multiplies through the parentheses. So this will be secant squared of 2x, then dx. So I'm breaking it up into two integrals here. And then I've got minus 1 times the tangent squared. So this will be minus the integral. And then the tangent squared of 2x right here can be replaced by secant. So I'm going to put, so again, I'm multiplying over here. This will be a minus tangent squared of 2x. Multiplying this minus 1 here. But I'm going to replace the tangent squared of 2x by secant squared of 2x minus 1. That's using this identity here. And then this will be dx here. So now, let's set this up here. I got the U-substitution that I'm going to use in this first integral. So this will be the integral, the tangent of 2x, that's the u. So instead of this here, tangent squared, this will be u squared. So I put the u squared here. And this portion right here, secant squared of 2x dx, right over here, that's replaced by du over 2. So this will be du can put it over 2 here. Or I can put the 1/2 out in front. I got that. And then this is minus here. So what I have here is just a regular integral with respect to x. Not using the u over here. So I'm going to write it this way then. Minus the integral of secant squared of 2x. I could break this up also into two integrals, but I'm going to leave it this way. Minus 1 and then dx. And then we just integrate here. So for the first one here, this is going to equal to integrate with respect to u here. So this will give me a u to the 3rd power. And then it divides over here. So it comes out as 1/3 here. So this will be a 6. Okay. So integrating with respect to u here, this is what I get. But remember, u is tangent of 2x. So I'll just go and finalize it here. So it's be tangent. It's just to the 3rd, 2x, and then it's over 6. I got that. And now this one's one integral, but again, it's like doing 2. So let's do minus, and we got the integral of secant squared of 2x. Well, I know the derivative of tangent is secant squared. So this would be a minus, and then it'll be tangent. So the integral of secant squared is tangent, but because this is a 2 here, 2x, I'm going to take the derivative of this, that's 2, and then I can divide this. It's the chain rule in reverse here. And then I got a minus 1 here, and a double and a negative over here. So minus minus makes this a plus. So that's a plus 1. Integral with respect to x. Of course, that's going to be x. And then we finalize it with the constant of integration, plus c. So we got tangent to the 3rd of 2x over 6 minus tangent of 2x over 2 plus x plus the constant of integration. This is your answer right there. Thanks for watching. We'll see you next time.